So in this video of chapter number 13, surface areas and volumes, we are finally going to start with the volume section of this chapter. Okay, so far we have just focused on the surface area section of this chapter. We saw different three-dimensional solid figures and we calculated their surface areas. We started with cuboid, cube, then we went to cylinder, we went to cone, and finally we saw sphere and hemisphere. For all these three-dimensional solid figures, we focused on how to calculate their surface areas. Now, from this section of the chapter, we are going to see the volumes of all these three-dimensional figures. Okay, so we are going to start with volume of cuboid and cube. Okay, so before we move on to the actual three-dimensional figures and start calculating the formulas for their volumes, let us quickly see what exactly this word volume means. So here is a short and quick definition of volume. Okay, so I'm going to read it out. Volume, so let me just mark an arrow. So this is the definition of volume. Okay, so volume is the space occupied by an object. Quite simple and straightforward. The space that an object occupies, okay, in our surrounding is called as its volume. For example, consider, okay, so for example, consider this box here, which is in fact cuboidal in shape. Okay, so this box, oops, so I'm being little, yeah, not very accurate, but this box will occupy some space, okay, in your room or in this in your surroundings. So the total space that this box occupies is called as the volume of the object. Okay, volume of that box. And if this box is empty, let's assume this box is empty, then you can fill some water in it. Okay, so the total water that the box will be able to hold will also be called as the volume of the object. Okay, so this is quite simple and a straightforward concept, that what exactly is the volume of an object. Okay, so the space occupied by an object is called its volume. Now we'll start with cuboid, the first three-dimensional solid figure that we have to see. So uh, this is a diagrammatic representation of cuboid. Now we know that a cuboid is always defined by three parameters. So let me note down the three parameters. So this is length. So I'm just going to write here length is equal to L. Okay, then this, okay, then okay, let's bring it at the center. So this is length. Okay, then this portion is called as a breadth. So breadth is equal to B, and then this portion is called as height. So height is equal to H. So any cuboid will necessarily have these three parameters for it to be visualized, for it to be constructed. What are these three parameters? The length, the breadth, and the height. In fact, we have seen how a cuboid is actually constructed. We basically take a rectangular sheet of paper and then we do this vertical stacking or vertical piling of the rectangular sheets of paper one above the other, and that is how we get this entire three-dimensional solid figure called as cuboid. So length, breadth, and height. Okay, so in order to calculate the volume of this object, you can think that how the volume of this object can be calculated. It will be basically area of this rectangle. Let me use a highlighter here. So we need to find the area of this rectangle. Okay, what will be the area of this rectangle? So area of the rectangle, area of, I'll say base, area of the base rectangle, okay, will be equal to length into breadth. Quite simple. What is the area of the base rectangle? Length into breadth. And if you multiply this area by this height, okay, if you multiply this rectangle area by the height, we will get the volume of the cuboid. Okay, because that is how a cuboid is actually constructed. You take one piece of rectangle and then you just keep on adding one above the other, one above the other, till you reach this total height h. Okay, so here I'm going to write here volume volume of cuboid will be equal to area of base rectangle. I'm going to say area of base rectangle into height, okay, into the height of the cuboid, and that is going to be equal to, I'm just going to write here, that is going to be equal to L into B into H. Okay, very simple and very plain formula for the volume of a cuboid. I'm just going to box it, very important. It's length into breadth into height. Okay, basically the area of this rectangle into the height. So we're going to use this formula to solve a lot of unsolved problems. So this was our discussion with respect to cuboid. Now let's come to the another figure, which is nothing but cube. So this is our cube. Now we all know in cube, the sides of the cube are all equal to each other. Okay, that is the only difference between the cube and the cuboid. Let's bring both of them into the picture. In cuboid, the length, breadth and height will be different than each other. But if the length and breadth and height are equal to each other, then we get a cube. Okay, so the main difference is that in cuboid, we have a rectangular base. Okay, the base is rectangular in shape, whereas in cube, this base is a square. Okay, that's it. That's the only difference. Otherwise, cuboid and cube are actually quite similar to each other. So in cuboid now, okay, so we don't have length, breadth and height. We just say side is equal to a, because this side is actually equal to this side, is equal to this height, is equal to this, is equal to this. It's all square. So there are basically all these squares on in all the directions. So these are all square, square, square. Okay, even this side, all these sides, edges of the cube. Okay, each and every edge of the cube is of length side. So its side is side is all side. I'll just erase this so that it doesn't look messy. Okay, so in cube all the sides are equal to each other. Let us say that each side of the cube is equal to a. So now how do we find the volume of a cube? So I'm just going to write here volume of the cube. So the concept is same. Volume will be the area of square base. Okay, area of the square base into height. Okay, so this concept is same to calculate the volume of any three-dimensional figure. We calculate the area of the base and we just multiply it by the height. So what will be the area of the square base here? It will be a into a. Okay, because it's a square, side into side. And what is the height? Height is also a, because it's a cube. All the sides are equal to each other, and that is equal to a cube. Okay, or we can just say it is equal to side cube. So side cube, this becomes the, let me box it, this becomes the formula to calculate the volume of a cube. Side into side into side, side cube. And the volume of our cuboid, yes, the volume of the cuboid is length into breadth into height. So in fact, if you see here, if length, breadth and height are equal to each other, then from this formula we can derive this formula. Okay, it is side into side into side, and all the sides are equal, so it's side cube. So these are the two important formulas that we have got to calculate the volume of cuboid and cube respectively. Now let us use them to solve different problems with respect to volumes of cuboid and cube.